So in terms of chapter 8, we are looking at loans in chapter 8. And today we're going to be talking specifically about something called a single payment loan, which basically means if you pay the loan back in one payment. And I need to zoom in a little bit on this, so bear with me just a second here. All right. So today we are going to be able to compute, as you can see over here, the lesson objective, compute the value or the maturity value and interest rate of a single payment loan. So vocabulary, we have single payment loan, promissory note, maturity value, term, ordinary interest, and exact interest. So we're going to be looking at a few different things to get things set up today. Calculation-wise, it's going to be a pretty similar thing to what we did back with simple interest. So when we were calculating simple interest back in, gosh, what unit was that now? Unit 4 or 5? Must have been 5. So it's going to be a simple interest calculation for a lot of what we're looking at today, not a compound interest calculation. So let's go ahead and get started here. It says, if you had a dream for starting a business, how would you finance it? It says, Haley Hannigan always dreamed of opening a ballet studio. She taught ballet at a local studio for several years in order to save money. But when the time was right, she took out a loan to open her business. So in order to start a business, oftentimes you need a lot of money up front. And so a lot of people get loans from banks called business loans that they end up having to pay back over time. And so here we go. A single payment loan is a loan that you repay with one payment after a specified period of time. A business may be short of funds and need to borrow money to meet its payroll or pay for inventory and supplies. The business owner could sign a promissory note with its financial institution. A promissory note is a written promise to pay a certain sum of money on a specific date in the future. So basically you're saying, yep, I'm going to pay this back. This is the day that I'm going to have it paid back by. And that's what a promissory note is. It says the maturity value of the loan is the total amount you must repay. It includes both the principal and interest owed. So basically all the money you borrowed plus the interest that was earned on that loan. Remember from chapter 5, that principal is the amount borrowed. So the amount borrowed plus the amount of money on top of that, the interest, is made up of the maturity value. A loan's term, a term is just the amount of time that a loan is granted. For example, a single payment loan may be granted for a number of years, months, or days. When the term is a specific number of days, the lending agency may calculate the interest in one of two ways. So depending on where you get a loan from, some banks or institutions will calculate loan based off of what's called ordinary interest, which we all know there aren't 360 days in a year, but it's a nice round number. And so they'll just say, all right, we take our interest rate over 360 days. Exact interest calculates down to the number of exact days in a year, which is 365. So there's two different ways of calculating interest here, depending on how the institution calculates it. So if it says that it's a certain amount of day loan using ordinary interest, you would end up using the ordinary interest formula, which divides by 360, as opposed to the exact interest formula, which divides by 365. And it'll tell you in the problem how to calculate it, which one to use, ordinary or exact. And so if you remember, simple interest right here, we learned this formula back in, I think it was chapter 5. Interest is equal to the principal value multiplied by the rate as a decimal, multiplied by the time. And time was based off of a year, right? Or part of a year. So if it was, make a couple of notes here. So time. We'll say year would be a whole number. Months or years would be whole numbers. So months would be number over 12. And then days would be one of those two, either 360 or 365, depending on the type of interest that's being calculated. So when we're talking about time today, anyway, time today will generally be one of these two: days over 360 for ordinary interest, or days over 365 for exact interest. And then the maturity value is just the original amount plus the interest, whether it's ordinary or exact. So those are the formulas that we have going on today. So that's what we're going to be looking at. So let's go ahead and flip to the second page of notes here, and we will get started on our first example. So example number 1 says that Anita Sloan's bank granted her a single payment loan of $7,200 for 91 days to pay for new merchandise for her candle shop. Determine the maturity value of the loan if the rate is 6% ordinary interest, so that's part A, or 6% exact interest. Now, in a lot of cases, you won't necessarily have to do both of those in one problem, but to get started, we're just going to see what the difference between those ends up looking like. So we've got our formula here. It says the ordinary interest is equal to the principal amount. So principal amount was $7,200 multiplied by the rate, which is here. This is for ordinary, so that would be 6%, which is 0.06. Multiplied by the amount of time. And we're talking about 91 days here. And for ordinary, it's over 360. So multiplied by 91 over 360. So the ordinary interest will be equal to, here we go, 7,200 times 0.06 times, I can open up a fraction here, 91 over 360. And we end up with $109.20 in ordinary interest. So 109.20 for that one. And it wants us to actually find the maturity value. So the maturity value is equal to the original principal, which was $7,200, plus the amount of interest, which is $109.20. So the maturity value will equal 7,200 plus the interest amount, which is 109.20. And if we add that together, we get a maturity value of $7,309.20. So if she takes that loan for 91 days, she will be told by her bank, hey, we'll give you this 91-day loan. But at the end of the 91 days, so we're going to give you this 91-day loan for $7,200. At the end of the 91 days, though, you owe us $7,309.20. So over those 91 days, it's going to earn that much in interest. So that is how this is calculated for ordinary interest. Now for exact interest, it's a very, very similar situation. It's just being taking the days divided by 365 instead of by 360. So the principal is exactly the same. And again, it says 6%. So it's the same interest rate as well. So 7,200 times 0.06 times 91 over 365 this time. And so it's going to look really similar to what we just did. So I'm going to have 7,200 times 0.06 times 91. This time is over 365. And it's $107.70. So 107.70 for this one. Which means that it's a little bit less money to calculate using exact interest versus ordinary interest. Ordinary interest is going to earn a few more dollars. And 91 days is about 3 months as well. So a few more dollars over those 3 months. So then the maturity value is going to equal the original principal, 7,200, plus the interest, 107.70, which ends up being $7,307.70. And so that's how we're doing our calculations today. That's it. I don't think there's too much to it, to be honest, because we're using that simple interest formula and we're just adding the amount of interest back to the principal value. So let's try these two at the bottom here, and then we'll take a look at an algebra example, which will be a little bit more challenging. So it says compute the interest and the maturity value for each loan. So down here, I'm just going to write 1A so we can work on that. It says Parker Logan purchased a new surfboard costing $600 and financed at 9% ordinary interest for 90 days. So 9% ordinary interest for 90 days. So ordinary interest is over 360. 9% would be 0.09. Principal value is 600. So we're saying, I'm just going to say OI for ordinary interest is equal to the principal value, 600, times 0.09. That's the rate, 9%, times the ordinary interest, so 90 divided by 360. So that's what we're using to calculate ordinary interest for 1A. So 600, down so we can see it a little bit better. 600 times 0.09 times 90 over 360. So when he pays that off at the end of the 90 days, it will have earned $13.50 in interest. So $13.50. In ordinary interest. So that means that the total, or the maturity value, so MV, maturity value, is equal to 600 plus the 1350, which equals $613.50. So $13.50 for the interest. $613.50 is how much he's going to owe for the entire loan at the end of the 90 days. All right. I'm going to give you 2 minutes, and I would like you to try to answer problem number 2. So I'm going to freeze my screen. I'll write my answer in, and then once you get your answers for these, let me know. And I just want to point out on number 2 as well, it's using exact interest on number 2. So just be careful about the denominator, what you're dividing by. So we're looking at exact interest for the second problem. And it's for, looks like 4 months instead of 3 months. Okay, does anybody have any thoughts on the amount of exact interest that is owed for the 120-day loan? Definitely be good to have a calculator for this. Use the Desmos one if you need to. I'll tell you what, I'll switch it over to that as well. So we had a $4,850 loan at 7%. And it was exact interest for 120 days. So multiplied by, here's our AB fraction, 120 days. And it was exact interest, so it's out of 365. So we're looking at $111.62 in exact interest. So that's how much money is going to be owed in addition to the loan that was taken out for $4,850. So the maturity value is $4,850, the original principal amount of the loan, plus the amount in exact interest, $111.62. So we're looking at a maturity value here of $4,961.62. So switch it back. You can see that. Right here. Are there any questions on this before we take a look at our last example that has to do with some algebra? Got some algebra to work on this next one. No questions? All right. So let's go ahead and take a look at the last page. So second type of example today is going to be an algebra question. It says, Claudia Valdez took out a single payment loan for $1,500 at 7.8% ordinary interest. Okay. So ordinary interest, we're looking at, so number over 360. This is our principal value right here. And then our percentage, 0.078. She took it out at ordinary interest to pay for her federal income tax bill. If the loan's maturity value, so the maturity value is here, $1,529.25. When would Claudia have to pay back the loan if she took it out on March 1st? Ooh, there's a question. When would she have to take out that loan if she took it, or when would she have to pay it back if she took it out on March 1st? So we need to figure out, first of all, the amount that she paid in interest. And then we're gonna have to figure out how many days the loan was for, and then figure out how many days after March 1st that is on the calendar. So that's what we've got to figure out here. So let's see, we have, first of all, find the interest. Now the interest should be a pretty simple thing to do because we know that the maturity value is equal to the principal plus the interest, or the interest is equal to the maturity value minus the principal. I'm just gonna go, I'm gonna get rid of the or, I'm gonna say, we're dealing with algebra. So the maturity value we know is 1529.25. We know that the principal value was 1,500. And we know that we were dealing with ordinary interest here. We'll just call this lowercase I. How about that? And then we're going to subtract 1,500. And that'll give us interest equal to $29.25. So interest, ordinary interest, $29.25 right there. That's the value that we have to plug in for our interest. And so our second thing that we have to do is a two-step process, because in order to get the number of days that she took the loan out for, we had to get the amount of interest first, which is a pretty simple thing, just straight subtraction. But now we have to use the interest formula, the ordinary interest formula, to solve for T. So let's go ahead and figure that out. Ordinary interest is, we said, was $29.25. The principal value was $1,500. The rate, 7.8% or 0.078, multiplied by T over 360, because we're solving for T. So it's three things that are getting multiplied together here. Now, fortunately, with multiplication, all of those things can be put over 1. And when you multiply, you can just multiply straight across the numerators and straight across the denominators. So that'll give us 29.25 equals everything across the top. So that's 1,500 times 0.078 is 117 times T. So we have 117 T on the numerator over 360, because 1 times 1 times 360 is just 360. Now our last step, or not our last step, we have 2 more steps. We now have to get rid of our denominator of 360, so we have to multiply both sides by 360. I'm gonna have to move things over here in just a second. So let's see. Those cancel out. So on the right-hand side of the equation, we've got 117t, so equals 117t. On the left-hand side, we have 360 times 29.25, which is 10,530. So 10,530. And so the last thing we need to do is divide by 117. So T equals exactly 90. 10,530 divided by 117 equals 90, which means right here, you can see the answer is already written in there. Claudia would have to pay the loan back in 90 days. So it's a 90-day loan. Great. Well, when is that? Because we're not, 90 days is important, but it says, when would she have to pay it back? So we have to figure out what date it is. So this says here, find the due date, use the elapsed timetable on page A110. Now I've included that once again in the notes section for today's notes right here, appendix A110. So let's see, March 1st is day 60 in the year. Okay, so March 1st is day 60. And we have to add 90 days to that. So 60 plus 90 is 120. So we need to go to day 120. If we take a look here, day 120 is April 30th. So that means she has to pay it back. Oh, hang on. No, 90 days. Sorry, I counted 60 days. 150. Sorry, day 150. That would be May 30th. I apologize. So we're looking at May 30th for the due date. 60 plus 90 is not 120. Sorry, 60 plus 90 is 150. So May 1st is day 150, March 1st is day 60. So here we go, let's see. So March 1st, day 60. So let's see. So day 60 plus 90 equals day 150. And according to that chart, day 150 is May 30th. So the answer to this problem, when would Claudia have to pay back the loan? She has to pay it back on May 30th. All right. Let's try this last one, and then we are done for the day. Here we go. How long would it take? So this one, we don't have to use the elapsed timetable. Now, we might have to on one or two of the questions on the assignment, but this one does not make us do that. So we just have to figure out how long. So number of days. How long would it take a construction loan for $548,048 to earn interest of $50,000 at 9% exact interest? So this is our principal value right here. This is exact interest. And then we've got 0.09. Now on this one, maturity value, principal and interest. Now the maturity value, that's fine. We could figure that out if we just added these together, but we don't actually need to do the maturity value portion on this problem. We just need to use the interest, but we're not using ordinary interest this time, we're using exact interest. So we're saying that the exact interest, EI, is equal to the principal value multiplied by the rate multiplied by time over 365. So that's the formula we're using for this one. And again, we're solving for T. So the exact interest, 50,000. So that number goes here, 50 grand, is equal to the principal amount. It's a big number, $548,048. I'm going to put that over 1, multiplied by the rate, 0.09. I'm going to put that over 1. Just makes the multiplication a little bit easier. Multiplied by T over 365. And the reason why it makes it easier is just the same reason as we did on the last problem. You just multiply straight across the numerator and straight across the denominator, which is nice because our denominator stays exactly the same. It's still 365. And we still have 50,000 over here. And then we're going to multiply the 548,048. So 548,048 multiplied by 9%. Make sure we have dollars and cents here. 49,324.32. So 49,324.32 multiplied by the variable T. And so these last two steps are identical to solving like we did back here, but instead of multiplying both sides by 360 first, we're going to multiply both sides by 365 because we're dealing with exact interest as opposed to ordinary interest. So bringing that down, on the right-hand side, we have the same number, 49,324.32 times T, time, number of days. And then over here is going to be a really big number, 365 times 50,000. There it is. That would be, what is that, 18,250,000. Without the commas, it's a little bit challenging, but it's 18,250,000. There it is. Last step, divide by our 49,324.32. And hopefully we'll get a nice number of days here. Divide by 49,324.32. What do we get? 370. And that's really close to being an exact number, but it is 370. I mean, the zeros here, they continue on for so long that 324 is essentially irrelevant. So we're looking at t equals 370. So how long would it take? It would take 370 days. So essentially 1 year and 5 days to earn $50,000 in interest, which is, I mean, that's a lot. That's a lot of money, a lot of interest to earn. So that is your lesson for the day. Let's go ahead and have a look at the assignment real quick. See if any of this needs zoom in here. If we need any of this to be 4 through 7, okay, that's fine. 8 and 9 determine the interest owed and the maturity value. So it tells you ordinary interest here or exact interest here. Determine the maturity value, ordinary and exact interest for number 10. Okay. And then let's see. I don't see anything here. Well, wait. Yep, number 12. On April 14th, Mikos Souvakis borrowed $100,000 to remodel his restaurant kitchen with a single payment loan at 10.5% ordinary interest. If his loan's maturity value was $104,375, when does Mike have to pay it back? So you will have to use this table here in order to figure that one out for number 12. And yeah, just that one there. Everything else does not ask you about dates, but number 12 does. So you'll have to think about the dates involved with problem number 12. Other than that, just use the formulas that are in the notes. So that's it.